Hey, seventh grade. So today we're talking about cross sections, and here you see a lump of Play-Doh, and this is in the form of a cylinder because I just took it out of the can. Yes, I have store-bought ones because my children are tyrants and they want Play-Doh. So looking at this, the first thing we need to know, what is a cross section? And if you have ever seen, those medical shows like House or whatever, they're looking at cross sections under a microscope. And so, what a cross section actually is, if you're talking about it medically like that, this is a piece of floss right here. My dentist gives me lots and lots of floss, and there we go. This also works with a butter knife or a plastic knife, which is what I usually use, but there we go. So a cross section is, holy crap, that did not work out. I'm very bad at cutting things apparently. So let me pause and go get a knife then. All right, guys, let's try this one again. So a cross section is when I don't have any plastic knives, so I wouldn't got a butter knife, is when we take a slice of something, and it's actually, like if you're talking about it medically, to look at something under a microscope, it's actually a very super duper thin slice of, let's say, spinal column, because spinal column is a cylinder-ish like that. And so this would be super duper thin, and you would put it on the microscope, and then the light would come up and shine through it. It would be so thin that it would be practically translucent. So in real life, that's what we're talking about as far as cross sections. Now, in math, this is actually so thin, sorry, I'm holding it up. This is actually so thin that it's actually two-dimensional. And so in real life, there is not really any two-dimensional thing. Like even light has thickness. A photon has mass and size, and it's incredibly infinitesimally small, but it still is. And so it's not nothing. And that's what 2D actually means, is that it has no thickness. Even the squares and triangles that we draw on our papers have thickness because the ink is there. But anyway, so what we're going to be doing today is we are going to actually take our Play-Doh here, and we are going to form this into some 3D solids. And so let's say we want to make this one into a cube. And so obviously, in order to make this cube, we would need six sides there, just like a die. And then all of them would be roughly congruent, so the same size, and they would all be flat. Now, not the best cube in the world, right? And so just in the interest of keeping this video kind of short, I'm going to say that's roughly good enough. Now, in Japan, they have actually taken to growing watermelons in cubic form. And the reason is to save fridge space. And of course, they're incredibly expensive. If you Google cube watermelons, Japan, then you'll find out what I'm talking about. But they grow watermelons in this shape so that they are efficient for the size of the refrigerator. Now, if this were a watermelon and I sliced it, let's say on the corner here, what kind of shape would I get? So there's that. So what kind of shape do I come out with? And this is actually what the cross section is. And that is a triangle. So looking at the shape that I created, looking at the shape that I created by slicing off the corner, I created a triangle out of a cube. Now, if I slice it, let's say, perpendicular to the base, perpendicular means at a 90-degree angle, the base is what it's sitting on, then what is this shape? Like if I took this and made it into a stamp, ta-da, what is that shape? It is a square. Okay, that is the entire idea behind what we're doing today. So I'm going to show you another video here in a moment discussing the paper that I have for you, the lab that I have for you to play with your Play-Doh. Remember, it doesn't have to be store-bought. Look at the video from last week about making your own Play-Doh with just some flour and some salt and some water. If you have food coloring, if you have, I heard Kool-Aid pouches make it smell good and make it colorful. All right, so I'm going to show you one more, and this one is called a triangular prism. Okay, so a triangular prism is a prism. Oh dear, do we know the difference between a prism and other things? All right, so a prism has rectangular sides. So it's like if I took some rectangular pieces of paper and I made them into a boxy shape there. Okay, so this is a triangular prism. This is not a pyramid. A pyramid is something that we will talk about in 8th grade. And the difference between a prism and a pyramid is that all these have flat sides that do not come up to one single point. This little pyramid over here has flat sides that all come up to one point. And so this is called a triangle prism, where all of its faces are rectangles and its bases are triangles. Two triangles connected by rectangles. This is a base with triangles for sides coming up to one point. And so that's the difference between a prism and a pyramid. So looking at this, if I'm going to slice this, so let's say I wanted to slice perpendicular to the base, what shape would I come up with? So what shape would the cross section be? And so when I open this up, what is, there we go, what is that shape? Okay, that's a triangle. Yeah, I know you know, sorry. Okay, so what if instead I go parallel to the base? What shape do you think that we would come up with if I slice this parallel to the base? Okay, come on now. Yep, are you ready? Are you ready? What shape is that? Okay, well, it's supposed to be a rectangle. Yeah, it's supposed to be a rectangle. So if I took this and I stamped it, it would just be that little skinny rectangle up here. So that is how we do cross sections. Now, please turn your attention to the next video where I discuss the paper, the lab for today.